Hello and welcome to our presentation of the paper called An Empirical Study on the Possible Positive Effect of Imperative Constructs in Declarative Languages, the case with SQL. This is joint work with Seyfullah Davulcu, Ole Werger and Volker Gruhn. My name is Stefan Hanenberg, and the paper was accepted at the 18th International Conference on Software Technology, ICSOFT 23. So let's give a quick overview of the results. First of all, we introduced imperative language construct in SQL. In fact, it was a quasi-assignment, so it feels like an assignment and a sequence of statements in SQL, and we called this language extension SQL assign. We performed a randomized control trial that compared SQL standard with SQL assign in a crossover trial. We had 24 students. The task the students had to do was they had to define a query on their own, and the task description was done in a step-by-step manner. The measurements were solution time, and the main result was that SQL assign had a strong and large positive effect. So on average, SQL assign required only 52% of the solution time in SQL standard. So what was the motivation for our work and the resulting research question? What we see today is that in imperative languages, there's more and more the tendency to introduce declarative constructs. So just taking a look into Java and C++, you see the introduction of lambda expressions, and you see that APIs such as the Stream API can be used as an alternative of the traditional definition of loops, well, now in a more declarative style. And there are already some experiments available that show the pros and cons for the introduction of such constructs in imperative languages. So the general question is, does it mean that the statement declarative over imperative holds? Well, it's probably not that easy, but let's ask the question from the other way around. So, do declarative languages benefit from the introduction of imperative constructs? In our case, we now check it out just for SQL. So we want to introduce an imperative construct in SQL and test whether it has any measurable benefit. So just in case you're not that familiar with SQL, let's give you a quick overview. So SQL is an abbreviation for a structured query language, and it is the standard query language for relational database systems. It's a declarative language where developers do not define in what order operations are performed. And just to give you a quick example, there's a SQL statement: select an attribute, count another attribute from a table, group by an attribute. So what does it do? It counts the number of rows for a given attribute called an attribute. And the characteristic here is developers do not define in what order the rows are grouped and the results are computed. So this is up to the database system. So let's give you an idea of a kind of query definition that we think that frequently occurs, which is called, or what we call, just a stepwise query definition. So the general idea is that a query definition can be done step after step. The example here is, give me all adults who live in Essen, and we define an adult as a person who's not younger than 18. So this, in principle, could be done in two different steps. The first is the selection of adults. The second step is the selection of adults who live in Essen. So the task already suggests that this can be done in two steps, but SQL does not require to define such query in two steps syntactically, so there are other alternatives for that. So let's take a closer look into stepwise query definitions and the language support that you get by SQL, and this is typically done via the statement with or the language construct with. And this is an example how with can be used. So you define a variable called amounts, and then you say how amounts look like or what the SQL statement is that where the result is stored in the variable amounts, and then you define a statement based on the variable amounts. And this is the alternative that you also can do in SQL. This is more in the spirit of declarative languages or a one-step definition where you say, well, select all customers from, and what you do now is you define an inner statement. And the inner statement is this statement that in the solution using with was the statement that was stored in a variable. And what you can see here now is in SQL, there is no need to use this language construct with. And actually, we think that we observed frequently that developers do not use with that often. So let's introduce the additional language construct that we used in the present experiment. And we want to make explicit the goal of the present experiment is not to design language extensions in SQL and to define a product and to sell this product. We just designed this language extension just for the purpose of the experiment. What we did is we made an explicit language construct for sequence of statements. And it looks very, very familiar to people who are familiar with imperative languages. So there is an assignment statement, or it looks like an assignment statement, where the left-hand side looks like a variable. And what you also have is the idea of sequences. So you make the first statement, and then you have a semicolon, and then you have a different statement. So just as an example, let's assume we want to have in a first step defined what a result is, and we say a result is a result of a given SQL statement, which is select something from a table. Then we define another variable, which is called another result, and then we define something else, some other statement. And now there is this, let's call it the main statement, which makes use of the two previously defined variables. So what does it mean? So it means that we have now a third alternative of defining the same query that we did before. And you see here on the slide just an overview of the three different syntax representations of the statements, and all the statements are equivalent. So they actually do not make a difference in the result. This is another point. We introduced SQL assign, although in principle we don't need it. So the with statement already does something very, very similar. But the situation that we think that exists is it looks like people don't use the with statement that often for reasons that are unclear to us, but at least, and we do SQL teaching at a university, we see that students typically do not see any need to use with at all. So what is the resulting question? It's quite obvious. Would developers benefit from the introduction of SQL assign? And when we speak about benefit, we do not speak about is it theoretically necessary or does it improve the expressiveness of the language? We're interested in, do developers in the end save time to use the language's extension SQL assign? And once more, our goal is not to advertise SQL assign as a new language extension for SQL. Our goal is not to provide a new tool to students or to developers or whatsoever. The only reason why we designed this language construct is because we're interested in the research question whether or not imperative or declarative language constructs have benefits in certain situations. Another thing that we should note is actually SQL assign just gives the impression of an imperative language construct. Actually, since we speak about queries and queries are side-effectory, the statement that you do with the aid of SQL assign, this query can be defined in SQL anyway. So there are already language means in SQL to define corresponding queries. As said, the whole goal is to have an experimental evaluation of the test, whether or not the introduction of an imperative construct brings benefits. And we first of all have to think about initial considerations for the experiment, because such initial considerations typically influence the design of the resulting experiment. So the first thing that we defined was that we want to have a crossover experiment. Crossover experiments are experiments where participants are tested under different treatments. In our case, it means each participant is tested under SQL Assign and SQL Standard. So there's one group where people start with SQL Assign and then do SQL Standard, and for the other group, it's just vice versa. Why did we do that? Well, we were not 100% sure whether the effect can be easily shown, and you typically run crossover experiments in such a situations where you're not 100% sure whether the effect will be shown up. Then we need to find a task. So as we said, the whole idea is to find a task where different statements should be defined one after the other, where a following statement uses the intermediate results of a previous statement. So what did we do is we want to find a task that matches the idea of sequential statements. And since we want to have a crossover experiment where where participants are using the one and the other treatment, it implies that two different tasks are needed in order to reduce the learning effect. So it probably doesn't make any sense to give participants the identical task 2 times, because once they solved already the task, they probably already learned enough to be faster in the second round. So what we decided instead is we need 2 different tasks which are somehow comparable with respect to the complexity, in order to use them then in a crossover experiment. Since we introduce a new language construct, this also means that we have to think about teaching. So there is the need for developers just to train this new language construct, and we have to tell them what this additional construct means. And in our case, we did a 15-minute introduction in SQL Assign. Let's give you a rough idea of how a task looks like. So this is just the description of the first task. In case you're interested in the second task, please take a look into the paper. So what we did is we defined 3 variables in terms of queries that have to be done. So we used the term quotient in order to say that certain fees for contracts somehow have to be determined. Then we spoke about a variable called debt, and we defined a variable called loss. And what we said then is we want to select customers who have a certain characteristic based upon a computation of the previously defined 3 variables. So this is the result. As said, we did a crossover trial. which means that we have our main variable, which is language, consisting of the treatments SQL standard and SQL assign. And we have a second variable, which is the group, and we have potentially interaction effects between both variables. And what we have in the experiment, or the result of the experiment, is first of all, we didn't have any group effect, which means that we do not have an indicator that starting with technique A or technique B had a result or had an effect on the result. The second thing is we didn't have an interaction effect between language and group. So it is again an indicator that we didn't have such carryover effects or learning effects, and which indicates for us that the idea of using the crossover trial was a good idea, and the use of two different tasks worked out. And now comes the most important thing. What did we measure in terms of SQL assign and SQL standard? So the thing is, SQL assign just required approximately 52 or rounded to 53% of the time it required to solve the same task in SQL standard. So there was a large effect that we measured, and you see the other values over there in the table: small p-value, large partial eta square. We should take into account that the p-value is very small and the effects are very large. Maybe the definition of a crossover trial was already too much for the experiment. So could we have achieved the same result if we just take a look into the first round of the experiment? So this is the situation where definitely no learning effect appeared, and so the potential risk of a crossover trial is not contained in this analysis. What we have is we still have a huge difference between SQL standard and SQL assign, and the result is very comparable to what we measured for both rounds. So SQL assign in that case is approximately 51% of the time SQL standard required, in comparison to the two rounds where it was about 52%. So what does it mean? So if we just use the first round, so if we would not have used a crossover trial, the results would still be comparable. So from our perspective, it means that the effect of the language construct is very large, and it can be even done with less effort than what we did in the experiment. So with only half of the effort, we could have achieved comparable results. So let's summarize and conclude the current presentation. So do developers benefit from the introduction of SQL assign? The answer is yes, and the effect is large because they just require 52% of the time those ones require to use SQL standard. So our more general question was, could declarative languages benefit from the introduction of more imperative constructs? And the answer here is also yes, at least for the given language SQL, and at least for the given experimental conditions. From the perspective of the experimental design, we could say that the experiment could have been executed with much reduced effort. In fact, the crossover was not required because we were able to detect the result even if we just consider the first round in the experiment. And if we want to summarize everything, we would say, well, the question whether or not imperative or declarative language construct should be used is probably not that easy. So we already know some experiments which showed that, for example, Java benefits from declarative constructs. And we have here, at least to our knowledge, the first situation where we also showed that an declarative language benefits from the introduction of a quasi-imperative language feature. So we think it's necessary to have much more experiments on this topic, and this is what we would like to see in the future in order to come up with better language designs. So thank you very much for your attention, and in case there are any questions, we'd be happy to answer them. Just drop us an email or leave a comment at this presentation. Thank you very much for listening.